Alright fam, so you want to be a math whiz. So I'm going to show you how to be a math whiz by using language multipliers to find the volume of the largest box inscribed on the left side, x squared over a squared plus y squared over b squared plus z squared over c squared equals 1. So it's not too complicated. The first thing you want to do is you want to set up the equation thingy, and the one you're trying to maximize is the volume. So that's x times y times z, which is pretty easy. Then you take the the x and y and z partial derivatives, and you put them in the little vector thing like this, of this equation and of this equation. Then you set it up like a normal Lagrange multiplier equation thingy like that. So you have the Lagrange multiplier times the limiting function over here, the partial derivative x, y, and z of that, equals the partial derivative x, y, and z of this function here. Then you set each of these things in here to equal to that thing over there. So we have this one here, and this one here. And you can notice here that they look very similar. That one and that one. Alright, let's go over to the back. So you have yz equals 2 lambda over a squared x, xz equals 2 lambda over b squared y, and so on and so on. So if you notice these things here, 2 lambda over a squared, 2 lambda over b squared, that's kind of hard to write those. So I made a little key here, and we're going to be using mn and p instead of whatever. And so you solve this for x. So xz over m x equals yz over m. Then over here we have y equals xz over n. And then if we substitute x into there, then we get y equals yz squared over mn. Then we divide both sides by y and multiply by mn. We get z squared equals mn. Whew, okay, now because these equations are symmetrical at the beginning, you can substitute, you can sort of like just switch them around or whatever. So x squared equals np, y squared equals np, and z squared equals mn, like I already said. So now you have these three equations. So now you take the original equation that you had, and you plug in all the variables that you had, but I'm going to convert m, n, np, and mp to their original form, and then I replaced x squared with x squared, y squared, and so on, and then multiply that all out, and you get this here. So you have 4 lambda squared over a squared plus times b squared times c squared plus etc, etc. Now if we multiply both sides by a squared, b squared, c squared, you get this, and you divide by 12 and take the square root, and you get abc over square root of 12. And because we're trying to find the maximum value of x, y, z, we're just going to take the positive square root of that and ignore the negative square root. Okay, now let's go down over here. So now we know that, what are we doing here? Man, I got lost. This is confusing. Oh yeah, now we have lambda, so we're going to plug in lambda into all these equations here. So we know x squared equals np, so np is n times p. So if you look here, there's a c here, c's cancel out, b there, b's cancel out. And oh, by the way, yeah, for these variables here, sorry, that's what I forgot. I plugged the new value of lambda that we got here. So you have the value of lambda, you plug lambda into there, and you get this new key here for m, n, and p. Then you plug those m, n, and p's back into the values which we got up there. So x squared equals np equals, you simplify it out, like I said, it's a times a is a squared, c divided by c is, yeah, b divided by b is whatever, to square root of 3 is 3. So x squared equals a squared over 3, and x equals a over square root of 3, and it's the same for the other two. Now we have this point here, which is the maximum point. So if we plug that into the original equation, which fx, y, z equals x times y times z, so you multiply all these three together and you get abc divided by 3 square root of 3. And now you're a genius.